Thank you very much for joining the session today. My name is Felix Baum. I'm working with Qualcomm at Qualcomm, and I'm responsible for our AI software stack. But the talk today that I'm going to have is going to be actually a mixture where I'll talk a little bit about hardware, a little bit about software, and we'll try to wrap it up quickly so you guys will have plenty of time to ask any questions. So catch me outside, and I'll be more than happy to go into excruciating level of details explaining you how things work. So with that, just to provide a little bit of history, I've been working at Qualcomm for over 8 years. So believe it or not, this wave that we're experiencing of GenAI and only hit us recently. But as far back as 2015, we had a number of our customers that slowly but surely transitioned from using kind of traditional signal processing algorithms for imaging, for audio, and other use cases to try to utilize transitioning to use AI and machine learning algorithm to do the same things. Back then, the hardware that we put together for them was pretty simple. We said, okay, well, all you need is just a couple scalar threads, for those folks that know what it is, and a couple vector engines so you can do math on the large chunks of large registers. And that was good enough back then. And again, I'm talking about like noise cancellation algorithms, simple bokeh effects, and things like that. If we go to kind of moving forward, you go through all the way into the 2022, you experience this growth in AI use cases where, yes, people still want to take picture. And back then, if those of us old enough to remember, you would take a picture, you would store it, and then you would go to your gallery and try to enhance it and make it look better and apply different effects. And then suddenly people realize that there's actually enough compute available, so you don't have to actually save the picture. As you looking in the preview window on your phone, you turn on you click on the camera app and you're looking at the picture. You can actually do a lot of real-time processing right on your image. And in a preview view, you will already see all these effects applied. All it took is just be able to process these pictures fast enough so you can actually sustain 15 to 30 frames per second rates. And that's where we, here at Qualcomm, added kind of a tensor processor, which is pretty much you have a still scaler to operate on the data and control flow. You still have a vector processors. And then we added a matrix processor, and we kind of said, yep, that's good enough. And then we got hit in 2023. And this is where we got hit by this wave of people coming up with all kinds of large language and large visual models, and coming to us and telling us, we want to bring these use cases and we want to run them on our mobile phones. Back then, we've done a lot of analysis, and the first thing we did is we got in Stable Diffusion to run, which was kind of okay, but Stable Diffusion by itself was not interesting, right? You take a text prompt and you generate a picture based on that. That's all Stable Diffusion does. It's not really a use case. Again, for those of you, and I know that might not be a popular topic here, but AI by itself is not a use case. You can turn it into the end-to-end solution. To turn into end-to-end solution, you need to do something else with it. Like, for example, so how many of us during COVID did teleconferencing, video conferencing? Okay, how many of you used custom filters? Okay, well, if I can take Stable Diffusion and plug it into my video teleconferencing app, then suddenly, as I'm starting my video conferencing call, it can actually ask me and prompt me and say, hey, what do you want your background to look like? And I will tell it, I want to look like I'm standing in front of, actually, I took a picture of myself right outside that jail over there. And I said, okay, well, I wanted my background to look like, I don't know, Golden Gate Bridge or something else. And it will immediately draw it, and then the whole video teleconferencing, it will use that as a background. That's a use case, right? Stable Diffusion by itself is not a use case. But to make that use case work, you don't need to just have Stable Diffusion. You need to have something to take your audio. You need something to clean it up, so you still need echo cancellation, you need noise suppression, you need a whole bunch of audio algorithms. Then you need something like a whisper to take your audio, or some other algorithm to take your audio, turn it into text. Then and only then you can feed your text into the Stable Diffusion to actually draw this thing. Anyway, just to show you that it's not just one model, it's not just one inference, it's all of them taken together what actually comes and needs to be considered when you're putting together kind of end-to-end use cases and building apps, particularly for mobile devices. I really appreciate that talk that we had at the beginning, one of the keynotes where they said, hey, look, there's so many NVIDIA GPUs shipped, but look how much total compute power available versus how many embedded NPUs shipped in the mobile phones or other devices, and the number is actually bigger. And it's actually kind of true because we're experiencing it all the time. Now, while I would love for you to deploy your applications and run them on mobile devices, the truth of the matter is there's still a lot of use cases that require connection to the cloud. For example, I can run, again, noise suppression algorithms on a mobile phone. I can clean up your voice. I can convert it audio into text. I can feed that text into the large language model Llama 7B or Llama 8B. I can maybe generate a summary to do as auto assistant. But then if my use case is help me to navigate my calendar and build my itinerary, at the end of the day, I still need some kind of connection to an agent in the cloud to be able to go there and send my summary of my conversation with my friend about the trip we want to have this weekend, and actually be able to purchase tickets, book hotels, and everything. For those of you visiting, I don't know how far you guys staying, but I'm staying pretty far. The only place I was able to find. And no, I actually used the real agent, the real person to book my hotel. Why on device? Why wouldn't we feed everything into the cloud and get it done there? Well, there are a number of reasons. I think latency is one of them, privacy is another one, personalization, and a few others. Again, catch me out after the talk, and I'll be more than happy to kind of explain exactly what and how and why we think those things are important. So on a Qualcomm side, what we have is, as some of you might know, is we ship chips. That's all we do. We build silicon to be used in mobile phones and computer devices. This is actually a Windows laptop that is relying on has the same chip that is in my phone. If you actually open the hood, obviously there's still CPUs are there, there's still GPUs are there, there's still our NPU there, and a few other things. And depending on what you're trying to do and how you're trying to deploy your PyTorch-based applications and algorithms, there are pros and cons of each hardware accelerator, and some things that you might want to consider why you're doing things. For example, I don't know if you're aware, but a lot of these phones, they have this, what we called here at Qualcomm as Sensing Hub. It's a piece of hardware that is always on. Literally, my phone is off right now, CPU is off, GPU is off, it's not doing anything. There's no memory, there's no nothing, but the sensor hub is running, and it's tracking my movements and doing things, and usually there's a microphone attached there, so if suddenly, and I don't want it to wake up, but if I say magic keyword, it will auto-wake up and wake up my phone, probably unlock it and do other things. So there are a lot of use cases that we see customers go and deploy that are purely based on this itty-bitty tiny NPU that's part of the sensing hub to do the noise cancellation and a few other use cases. Then obviously, if you turn things on, you can do more things with the sensing hub. You have access to the larger memory and more resources. CPUs, we see our customers deploy their algorithms and run applications on CPUs all the time. GPUs, obviously, are quite popular to run machine learning models. But what we have done over the last, I would say, 8 years plus minus, is we built this highly dedicated hardware accelerator specifically built to run machine learning algorithms. And some of the use cases that we see customers use there have to do with the camera and imaging and other things. And that was up till about a year and a half ago. And that's when customers suddenly showed up and told us that, well, it's not enough for us to run bokeh effects. It's not enough for us to run low light improvement algorithms. If you're taking a picture late at night, but you're still in a bar and you're drunk, but you want your picture to come out really good. Not enough. Now we want to do all of that, and we want to run AI assistants. We want to run large language models and other algorithms like that. So what we have done is we've done a couple things. Obviously, as a hardware company, we can't just throw hardware at customers and expect them to use it. We have to build enough software for you folks to utilize it and make it work within your PyTorch ecosystem of products and tools. All right. So our software stack is pretty tall. We have, depending on where you're coming from, we have all kinds of converters, all kinds of quantizers. We have runtime frameworks. We support runtime frameworks from different vendors. Obviously, if you're here as part of the PyTorch community, probably ExecuTorch is one of the runtime frameworks you want to use. But there are other weird people out there that use TensorFlow Lite. They use Onyx Runtime, and a couple others, like DirectML. We provide customers with compilers and libraries and all kinds of tools. We also have done something on the left side where we try to help community to get to the end faster, meaning that take a model and get it to run as fast as possible on a silicon, so you can just try to see how it works. And to make so, there are a couple of workflows or approaches. First of all, if you look at your left side. If you look at your left side, what you'll see is you can come to us from PyTorch, or you can use your favorite framework and convert it to Onyx as an interchange format, come to our tools, and then offline quantize it, convert it, do all kinds of things for it, optimize it to be able to get it into the intermediate representation that we can actually compile and generate a binary out of it that we can run either on a CPU using CPU-optimized kernels, on a GPU using OpenCL kernels, or on our NPU, and our NPU go by the Hexagon trademark, Hexagon NPU. So there's a Hexagon-optimized kernels. You can do it all offline. Any idea why? Nobody? Well, if you have a small model, you can do it online. And as a matter of fact, up until a few years ago, everything what we've done is it was all online. You come to us with a model, intermediate representation, right there on your mobile phone at the time of you starting your app. We would actually go generate binary and load it into our NPU and execute it. But you guys are unreasonable. And you start making your models larger and larger and bigger and bigger. And it got to the point where it became prohibitively expensive, because if you start your app and then you have to sit in front of it for 2, 3, 4, 5 seconds or minutes waiting for us to kind of go through and try to compile it online just in time and generate as fast and efficient binary as possible, that application is unusable. So we had to do a lot of things and pushed it offline. Nowadays, if you show up with a large language model, large visual models, it will take more than minutes for us to just compile it online. So that's why kind of a lot of the processing right now got pushed into the offline. But it works. It worked great. And we are more than happy to provide our tools to the ecosystem. In fact, we only have one set of tools. So we don't discriminate whatever you are, phone manufacturer or our partner or a grad student. We give you exactly the same software, exactly the same tools, and we enable you and allow you to go and write your applications and offload them to our NPU and get the best performance and at the lowest power. Because to us, and I don't know about you guys, but I just checked my phone, and I only used my phone a couple times during sessions because I was paying attention, and it's still only at, 50% of the battery. So if I run out of assistant there and suddenly my phone drains in half a day, that's unusable. Now, on the right side, what you see is the work that we've done with our friends at Meta, where to help PyTorch ecosystem to launch and run these models on device faster, What we've done is we enabled this ExecuTorch path, just like what we've done with a TensorFlow or on XRT. You get an ExecuTorch. ExecuTorch comes out of the box with a CPU acceleration and a GPU acceleration. But we worked very closely with Meta to be able to build this NPU delegate. And what that will allow you to do is it will allow you to take your model, and instead of running on a CPU, getting you 1Z, 2Z inferences a second, or push it to the GPU and get 10 or 15 or 20, but drain power really, really quickly, will allow you to run at hundreds, if not thousands, inferences a second at just quarter or even less of the power that you would have consumed. So that's kind of the approach that we've taken. And what we have also done is understanding where the customers come from. We realized pretty quickly that expecting experts to take our software, to actually read our documentation, to take the model, quantize them, convert them, and to do everything that they need before they can actually get to the compilation of the model and get it to the device, that's going to take a very long time. And I don't want you to be like the previous presenter. I don't know if you were in the audience, but he said something along the lines that their IT system sent them a AC bill because of how hot they were running their GPUs. So we don't want you to be in this situation. So what we've done is we put together this concept of AI Hub, where you can go grab a model from Hugging Face or bring your own. We have about 45, I think by now it's almost 80, different Snapdragon devices in the cloud. Some of them are different versions of the mobile phone, some of them are computers like this, some of them are IoT devices, and so on. And then you can take your PyTorch program, you can change, as you can see here, 5 lines of code, and suddenly your model runs, will be compiled, built, loaded into one of these devices in the cloud, executed on that NPU, and then you get the results of how fast it is, how accurate it is, and things like that. So how does it work? Well, I kind of walk you through that. You pick a model. I forgot, I think last time I looked, there were 80 or 100 models that we already tried for you, and they're all linked at the AI Hub, so you can go grab them directly. Or, again, like I said, you can bring your own. You can pick a target. You can go through our whatever tool and say, I'm looking for IoT device, or I'm looking for a wearable device. I'm looking for like a goggle-looking thing because that's what I'm targeting, or a mobile phone. You can actually pick a runtime. So you can go and say, you know what, I'm using an Android device, so I probably want to use TF Lite, or I want to go use ExecuTorch soon. Or if it's a compute device and Microsoft, and you bought into the Microsoft ecosystem, probably it's going to be on XRT runtime framework. So again, you pick a model, you pick a target, you pick a runtime you want to use to delegate your workloads, and then you go through it to put your model together and load it onto the device, deploy it, and get results. Okay. So let's talk a little bit about what we've done with an ExecuTorch team at Meta. Our delegate supports various quantization techniques and schemas. We also support mixed precision models and custom quantization annotations. Pretty much, this is the only way for you to run your large language models on an edge device. If you're looking at something like Llama 7B, how much RAM do you need to run it? Any ideas? So let me actually flip it around. How many people here have cell phones? Come on, everybody has. I know some people have 2. How many? Keep your hands up. Keep your hands up. How many folks have phones with 12 gig of RAM? 8? 6? Sorry about that. All right. The truth of the matter is, if you take a Llama 7B, or 8B for that matter, and you try to run it on a mobile phone, the only way you can do that is if you try to quantize it and shrink it down as much as possible. And what we figured out is the only way we can minimize the memory footprint, but still allow you decent enough accuracy is if we go with a 16-bit activations and 4-bit weights. And then there are a few other techniques, as you can see. 16A, 8B, and all those, 8Ws and things like that. So let me ask you again another question. So if you take 7B linear parameter model or 8B linear parameter models, and even if you go down to 16A, 4W, how much RAM do you need to run it? Any guesses? Who thinks it's 5 gig? Oh, come on. Nobody has 16 gig phone, so no. So 16 gig, no. 8 gig, no. Let's go the other way around. The truth of the matter is, if we take 8 billion parameter models, we can shrink it to about 3.5 gig. So think about it that way. You have a phone. It's an Android or Apple. Doesn't really matter. Take 2 to 3 gig for an operating system and all the other stuff that's happening there. So that's 3 gig off the top. You add in, you're trying to run your application. So let's say it's really, really bloated. I'm not pointing finger at anybody here, but let's say it's another gig, half a gig. So you're already 3.5 gig for the OS, another half a gig for an app. So you're already at 4 gig. Now try to add on top of that 3.5 gigs for your large 7 or 8 billion parameter model. You pretty much 6 gig RAM devices. Those of you unfortunate people, and I know who you are, you're pretty much out of luck, right? You need at least 8 gig or more. Anyhow, the only reason I'm bringing it up is, and trying to kind of use this obnoxious illustration, is just to show you that when we're working with customers to help them with these use cases, there are a lot of work that we have to put in. And yes, it takes a lot of work to actually get these models working, but it's even more work to try to figure out how can we actually make it work within the constraints of device, meaning that you can still use device for at least a whole day. We're not going to hit any thermals. Again, overheating your GPUs probably and turning ACs, okay. But if your phones start overheating, probably you're not going to like that. So we've done a lot of work to be able to accommodate these demanding use cases. A lot of work that we've done to increase accuracy, to speed things up, and our delegate also utilizes model sharding algorithm. Let me see if I have time. Oh, I'm almost out of time. All right, so let me wrap it up a little faster. We still are not done. As you've heard in the first session, second session, ExecuTorch is going to be beta soon. So we still have some work to do. We're trying to still optimize for performance. We are trying to add LoRa. How many people know what LoRa is and why you need it? So why do you need it? It's even more important on a mobile device, because imagine that I have, like I told you, right? So how many people have more than one texting app on their phone? Okay, so imagine I have, what's your favorite one? Well, it's a Meta, so it's probably Facebook Messenger. So we all have Facebook Messenger, and I don't care which the other app you have, right? I want to have a Llama 7B to work for these 2 apps and help me to answer text, because a lot of texts that I get, I can just auto-generate responses without even me typing things. So if I want to have, for each texting app, its own Llama 7B to help me to summarize the texts and provide answers, that's 3.5 gig for one, 3.5 gig for another. That's not going to work. So what we've done is you have to enable LoRa, you have to enable weight sharing, you have to enable a few other things to be able to reuse all this data, so you don't just blow past your memory, you don't blow past your RAM. And that's something that we're doing. Block quantization to improve accuracy, and a few other things that we're still working on with the team at Meta to make sure that the solution that we have works and helps PyTorch community to be able to take their use cases, build them, and then run them on device and get the best experience. So with that, I'll wrap it up. Thank you very much for attending. Any questions that you're comfortable asking in front of everybody? And if not, I'll be here after the session. You can find me, and feel free to ask in the hallway.